Sorry about my heater. I know that's audible right now. But here is my physics final. Nanocoil Air Purification by Rutger Volkema. The problem, microplastics are ever present within our planet and even our own bodies. There aren't many ways of removing microplastics, but there are ways to limit the consumption of it. Microplastic pose a threat to life by impacting fertility, disrupting hormones, causing infections, and increasing cancer risk. Some of the physics concepts involved with the solution is fluid flow and particles. My solution, the Nanocoil air purification system. Nanocoils are an experimental, incredibly tiny technology that is coated with nitrogen and a magnetic material known as manganese. These two chemicals interact with the nanocoils to create reactive oxygen molecules, which then attack the microplastics. This device is currently being tested in water and has been proven to remove a considerable amount. That amount, I believe, was 30% to 50%. There are, however, two methods of ingesting microplastics outside of consumption, though. Inhalation and absorption through the skin can allow small pieces of plastic to get into your body. We can work towards eliminating some particles inhaled by combining this invention with another. A whole home ventilation system works by exchanging the stale air inside your house with fresh outdoor air. That, however, brings with it some harmful things in the air, including microplastics. With mechanical ventilation in particular, that air is leaving and traveling through ducts to control the airflow. By including the coils in the ducts, one could assume that as the air travels into your home, the microplastics it may carry are attacked by the molecules produced by the coils, converting the particles into harmless salt compounds, water, and carbon dioxide, which can then be filtered out of the duct system. Some of the physics concepts involved, again, particles, the minuscule properties of the elements involved in the coils, along with the microplastics themselves, means that knowledge of particle behavior is needed. Fluid flow, because of the need to know about ventilation systems and how air flows in and out of the ducts involved in mechanical ventilation, one needs to understand fluid flow. Some relevant equations are mass density, which is density equals mass over volume, and pressure, which is pressure equals force perpendicular to surface over area, and viscous flow, which is the volumetric flow rate equals the pi times the tube radius to the fourth power times the pressure difference divided by 8 times viscosity times the tube length. A theoretical explanation for the equations. The viscosity of the air is incredibly relevant when it comes to predicting how it'll flow in a duct. Understanding the pressure of the air is needed to know its viscosity because of its presence in the equation. I added the mass density equation because I feel like it could be useful to understand how the particles within the fluid might interact together, even if their masses are quite small. The first part of my innovation claim, my idea combines existing theoretical nanotechnology focused on earth restoration and commonly used methods of indoor ventilation to clean the air within a space and limit microplastic inhalation. The solution's reusable, earth-friendly, and could help limit future health issues. And then I have a visual to the right about how microplastics in the air enter your body. It goes to the brain, the respiratory system, lungs, liver, kidneys, the skin, digestive systems, placenta, stomach, spleen, and breast milk. So, limiting microplastics from the air can remove microplastics from these systems. Innovation claim part 2. The cost of manganese is apparently 30.25 CNY per metric ton. That equals about $4.30 per ton of manganese. Solid nitrogen is allegedly 98 cents per pound. I believe they're using melted down versions of the solid elements because that's what I envision when thinking of coating something. Very little of the bought elements will be used per coil because of the minuscule size of each one, measured in literal billionths of a meter, meaning they're actually incredibly cheap to make. These can hopefully be deployed in every home because of how cheap they are to make. I do hope the nanocoil at minimum becomes popularized and used for water purification and eventually purification of other systems containing microplastics. The slides and research were done by me. The nanocoil concept is by that individual and their team of researchers. And some of the resources I used are as follows. My reflection, although not necessarily physics and instead chemistry, I learned that certain chemicals can attack microplastics. Nanotechnology research, which does involve, that's meant to say physics, led me to discover the nanocoil, which is currently being researched. I genuinely do hope it's incorporated in water purification areas everywhere so that future generations aren't affected so much by harmful microplastics. Understanding the nanotechnology and how microplastics are absorbed in other ways led me to combine existing concepts to create a new air purification system to rid the air of microplastics within buildings.